All right, hello. So this is going to be a quick overview of private data, the private data features we're building into Ceramic. So to start us off, so far, Ceramic has mainly been a network for public data, and this is what we're sort of looking to change. And in doing so, we're sort of exploring the idea of some data on Ceramic, or potentially all data on Ceramic, being private by default and only sort of made public if the creator of that data, the controller of the data, actually chooses to reveal that. So what I'm going to talk about here first is sort of a proof of concept that we've been building. So I'm going to talk about the general flow and then show you the actual demo. Okay, so we're doing this in two phases, phase one and phase two. What we have a demo of today is the phase one. So phase one is basically an access control layer on top of the Node API. And phase two is actually adding access control to the networking layer of the Ceramic protocol. So let's have a look at what this looks like. So in this example, we have two users. They access a web app on separate machines, but this web app talks to a single Ceramic node. And so here we have user one on the left, and they write a piece of green data to the node, and writes in the web app, goes down to the node. And then by default now, user two can't actually read the data from the node. Even if they make a request to read, they wouldn't see that this data is there. But then what user one can do is say, hey, I want user two to have access to the data. They can sign a read capability, then hand that over to user two, and user two can essentially access this data using this. So they basically send a signed message saying hey, I'm user two, and here's my read capability. The node can see that, verify that, and then send back the actual data of user one. So in this way, we can see how the node sort of can enforce the access control logic. And just to clarify one point is that this does not do encryption in any way. What we're mainly focused on is just more of the physical access control. So who actually has access to read the data in the network. And so I hope this will become a little bit more clear as we go into the second example, where we extend this into the networking layer of Ceramic. So in this setup, which is phase two, we have two users and they're interacting with separate nodes. We could imagine this being the user's own nodes, or we could imagine this being nodes operated by different applications. So here, user one writes some data to the app. First node gets that data and stores it. Now, user two can't actually access that data, and the user two's node wouldn't even be aware of that the other node has the data. But then again, user one can delegate this read capability to user two, and then user two can further redelegate that down to the node. And now the node can go out into the network and discover the data that is on user one's node and get it back, and then propagate it back to the user. So in this way, the user essentially has now been able to retrieve the data. And so what this means is essentially the data lives locally on specific nodes, and it's up to each user to decide how that data is propagating through the network. If they're really paranoid, they might just want to run their own node, or only trust an individual company or organization with their data. Or they can sort of delegate it out to a lot of people that can then further sort of retrieve it in different parts of the network. All right, so let's have a look at the demo. So the first thing we're going to do is just start the Ceramic node. So here we have Rust Ceramic called Ceramic 1. We check down on a feature branch, and we're just going to use cargo to start this node. And so, yeah, that's basically running. And then I'm just gonna start the web app. And then we go back here and load it in the first window here. Let's see if this builds. So let's connect the wallet. Let's try the same. Okay, so I'm already connected, and it looks like my session is actually persisted. I'll show you more clearly in the other part of the demo what happens. But actually, let me do that right now. So first, disconnect here, and I'm just gonna clear out the cache. Delete this database. Okay, let's try this again so you can see the full flow. So it's the frame. And now you can see that it connected to my address, but then it's asking me to sign in with Ethereum. And so you can see like this is my Ethereum address, and you give this application blah, blah, blah. And the key thing here is we're delegating to this URI, which is a session key that lives inside of the browser. And then there's some other metadata. And specifically here is like the capability we're giving to this session key. So the session key gets read and write permission for the data that is using this model, this data schema. We sign this, and now we can just like write something here. Create that. And so now we created that, it's been stored on the ceramic node. And now if we go to over here, second tab, and let's try to connect with MetaMask over here. You can see MetaMask pop up. We're using count 3. Same thing happens here. Sign in with Ethereum request. A different session key this time because that's automatically generated randomly in the browser. And here, read capability for the same data model. So we sign in, and we're going to go to the read tab. So if we only copy the stream ID from over here and paste it here, we're actually going to get, we're not going to be able to load anything. So we actually need this capability. So if we just like pretend we have the capability, this will simply just not work. But what we can do now is to essentially copy the Ethereum address, paste it here, we can create the capability. And so now we copy this and paste it over here, we can load the data. And so what this does is like this on this end, the session key that we had, when we paste the Ethereum address here, the session key further delegates the capability from the session. So we delegate first from this account over here down to the session key that lives in the browser. The session key further delegates to the key or the address, the other user's account. So that's what we can see here. This actually encodes sort of these delegations. And when we paste it over here, what happens is that we have the delegation from this account that's in the wallet here to the session key, to this other session key. And then we have the delegation that goes to our Ethereum address over here. And then basically whenever we send a read request to the ceramic node, the session key on this side basically sends a request that embeds both the capability from our wallet on this side and the capability from the first user, and basically proving permission that we have access to read their data. And so we can read out this data over here. And obviously this can be this can be extended to like not load a single stream ID because it might seem a little bit silly that we have this whole thing and reading this small thing. But this can, once we have this capability, you can imagine it's like reading out an infinite number of like data points. All right, so that's it for the demo. Please follow up with any questions you might have. I'm happy to chat more about this.